Let us learn to write formulas for ionic compounds. So if I have an ionic compound that forms from aluminum and oxygen, how will I represent that? I don't have to give you the number of aluminums or oxygens. We're going to learn how to deduct this using our knowledge of charges. So if we wanted to do aluminum and oxygen, the first thing that we want to do is write the charge, the symbol and the for the metal cation and its charge. So aluminum will always have a positive 3 charge. Remember, we learned that we can predict the charge of some elements on the periodic table based on their position, and aluminum is one of those. It will always have a positive 3 charge because it's in group 3A. Oxygen is in group 6A, and it will always have a negative 2 charge. Okay, so we write the symbol for the nonmetal anion and its charge. Now we write them, the metal with its charge and the nonmetal with its charge. We rewrite it, and then we're going to do something called a crisscross. So the charge without the sign becomes the subscript for the other ion. So for aluminum, it's got positive 3. We're going to move that as the subscript for oxygen, but without the charge. And then for the charge on the oxygen atom, we're going to move it and make it the subscript for the aluminum ion, and it's going to be without the charge. So it becomes Al2O3. And now the fourth step is to reduce the subscripts to the smallest whole number ratio, but they're already 2 to 3 is already in the smallest whole number ratio. If we reduce it anymore, it'll be 1 to 1.5, which is a fraction. We do not want fractions, okay? And then we check the charge. Aluminum, we have 2 of those at a positive 3 charge each, so that gives us positive 6. And we have 3 oxygen at a negative 2 charge each, which gives us a negative 6. So those add up to 0. So you can see our cation charge canceled our anion charge. Now let's do one more example, this time with magnesium and oxygen. And let's do it right alongside our rules. So write the symbol for the metal and its cation and its charge. So that's going to be a magnesium plus 2 because magnesium is in our group 2A. Oxygen minus 2. We write them alongside each other. And then we do our crisscross motion where our subscript or superscript here becomes our subscript down here. And we do the other way around. And now here we want to reduce the subscript to the smallest whole number ratio. We have a 2 to 2, which can be broken down into 1 to 1 ratio, right? So we just write it like so. Again, we don't write the ones because it's already assumed. And then we want to check our charge. Our charge for magnesium, we have 1 magnesium with a positive 2 charge, and we have 1 for oxygen with a negative 2 charge, and that gives us 0 net. So this is our chemical formula here. Okay, go ahead and try this on your own. You can go back and look at the rules if you have to for now, but you should be able to get good enough at it that you don't have to look back. But we always write our symbol with the charge, potassium plus, and then we have our oxygen with a negative 2 charge. Okay? And then we want to do the crisscross. So we end up with 2 here and a 1 here, but we can simplify that to K2O. And that becomes our final answer. If we want to do a charge check, you can do that in your head, but we have 2 potassiums with a positive 1, so that's positive 2. And for oxygen, I have 1 oxygen with a negative 2 charge, which is negative 2. That gives me 0. Now write the formula for the compound formed from strontium and chlorine. Strontium is Sr, and it's got a positive 2 charge. Chlorine has got a negative 1 charge, so you can write that if you need to. We want to do our crisscross motion, and so we end up with a 1 here and a 2 over here, and we can simplify that as SrCl2. And then you can check the charge. Positive 2 here for strontium, we have 1 at positive 2, which gives us positive 2, and we have 2 chlorines at a negative 1 charge, which gives us a negative 2. That makes it charge neutral. Now we do the same exact process for polyatomic ions. So when we write formulas for ionic compounds containing polyatomic ions, we just have to remember the charge on the polyatomic ion unit. So if we have calcium, we write it as, we write our cation first with its charge. Calcium will always be positive 2. And we write our nitrate ion now with the negative on it. Now we want to crisscross our charges. And so this comes down here, and this comes down here as 2, and this comes down here as 1. But here we want to make sure to put parentheses around the nitrate so we don't get confused. So it becomes calcium NO3 with a subscript of 2 on the parentheses. And we make sure with the charge because we have 1 calcium with a positive 2 charge, so that's positive 2, and we have 2 nitrates with a negative 1 charge, which is negative 2, and those cancel out. Okay, let's do it for aluminum and phosphate. Aluminum, like we said, is always positive 3. Our phosphate group is PO4 minus 3. So let us rewrite it and crisscross our charges. So this is going to go down here. So now that we have put a 3 on there, we have to put parentheses around the phosphate. And this is going to go down here. Okay? Well, we can write this as aluminum PO4 3. But guess what? We can simplify this to a whole number ratio. A 3-to-3 ratio is same as saying 1-to-1. So aluminum phosphate. And now that it's a 1-to-1 ratio, I don't have to put parentheses around the phosphate. So I can just write it as AlPO4. Okay, go ahead and give this a try on your own. Write the formula for the compound that forms from sodium and sulfide ions. Okay, our sodium is Na, and it always has a positive 1 charge. Our sulfite ion is SO3 with a minus 2 charge, right? Now we want to do our crisscross, and we will bring this down here, and we will bring this down here as 2. But we don't have to put parentheses around the SO3 because this is a 1, so we can write it like so. And we check to make sure that we have simplified it down to the simplest whole number ratio. And this is 2 sodiums for every 1 sulfite, so we are good. We can't simplify it anymore. And our charge is we have 2 sodiums with a +1 charge to give us +2, and we have 1 sulfate with a -2 charge, which gives us -2, so it cancels out.